Hey, hi, this is Kunal, and today I am going to discuss one of the case study for natural language processing called, automatic ticket classification that falls under the topic modeling and topic classifications problems. So before going into the, you know, uh, deep into the case study, let's see what are the steps we have to work on or steps involved in solving a topic modeling and topic classifications problem. So before going deep into the steps, let's try to understand some of the terms. Uh, so basically, what is topic modeling? So topic modeling is basically a machine learning technique that automatically analyze the text data to determine which cluster the topics belongs, and where we have a set of documents, and it scan the document, identify the hidden patterns, and automatically cluster the word group to a particular one of the cluster. And it is a unsupervised machine learning technique. So basically, we have to provide a number of cluster, how many cluster we need. Accordingly, it will, it will, it will assign, uh, it will group the topic to one of the, one of the clusters. Basically, using the topic analysis models or topic modeling classification, business are able to upload the simple task or repetitive task to the machine. So this is how basically work. We have a bag of words or corpus text. We are feeding the data into the topic modeling and determine the topic. So there could be some of the different kind of most frequent word. It could be fall into the both of the cluster. Based on the most frequent occurring words, they will determine which cluster it belongs. And topic classification. So topic classification basically it is a supervised machine learning technique. So we must have some label, and it requires training. So basically, topic classification need to know the topics of a set of text before analyzing them. I mean, we need to provide the label and some of the text. So we have to provide both data, text and label, to build the a topic classifications algorithm. And once we feed the data to this model, they will determine which topics it belongs to. So we can say that unsupervised technique are a short-term or quick fix solutions, while supervised technique are a most of a long-term solution that will help you to business grow. So what is the difference between topic modeling and topic classifications? Okay, so basically, basically what it does, both topic modeling and topic classification can be used to identify the topic of a set of customer review, social media, text, IT logs. Basically, what topic modeling do, it try to refer which cluster the text belongs to. It doesn't provide the labeling of the data. We have to understand the cluster and provide the labeling. While topic classification, it is a package topic. I mean, it will have a topic with the labels, and when you provide the text data to the topic qualifications models, it will predict the label which the cluster belongs to. So basically, topic modeling algorithm, what it's not a collection of expression and word that it things are related, and leaving you to figure out those relations mean. So you have to manually assign the label. You have to manually understand which topic this cluster belongs to. While topic classification, it is give you the label, topic label. So that is the differences we have. What are the different algorithms we are having for topic modeling? So we are having latent semantic analysis, that is called LSA, latent dirichlet allocation, LDA, non-negative matrix factorization, that is called NFA. So today we'll perform a topic modeling using the NMF, and I'll have a different a session on topic modeling and topic qualification in more details into the different lectures or different video. Here, our focus will be to have a case study how we are going to use this technique to build a ticket classification, uh, automatic ticket classifications, uh, uh, model for automatic ticket classifications program. So this is our target today. So we will discuss all those things into the very brief. What are the steps we need to develop a algorithm for automatic ticket classification. So automatic ticket classification, basically what we have. Let's go through the problem statement here. So you need to build a model that is able to classify customer complaint based on the product and services. By doing so, you can segregate this ticket into the their relevant categories and inferences. Help in quick resolution of the issue. You will be able to doing topic modeling on the JSON data. So we are having the JSON data. We don't have a CSV provided by the company. Since the data is not labeled, you need to apply NFF to analyze patterns and classify ticket into the following 5 clusters. So we have a banking customer data, and basically customer, what customer are talking to the bank. So it's a kind of feedback data we have, and we have to analyze the data and can categorize into the each of the cluster. And when we find some unseen data and fit to the model, it should able it should be able to identify which categories the customer is talking about. So we have a credit card and prepaid card. That is the one label or one class, a cluster, we can say that. Bank account services, theft or dispute reporting, mortgage and loans, and then others. So these are the 5 clusters we have. Uh, from these are the 5 clusters we want to classify the customer complaints or the messages. Uh, so we have to build the model uh, to classify which one of the cluster or which one of the services uh, the ticket belongs to. So with the help of ticket, a topic modeling, you will be able to map each ticket to one of the respective department category. You can then use the data to train any supervised model such as logistic regression, decision tree, or random forest. Using the trained data, okay, using the trained data, you can classify new customer complaints support ticket to this relevant department. So let's go through some of the high level, details. What are the steps we are going to perform to, to achieve this task. So before going into that, let's talk about some NFA. What is a NFA? So NFA is nothing but a non-negative matrix factorization, or NFA is a method used to factorize non-negative matrix X into product of two lower rank matrices AB such that AB approximate an optimal value of X. I mean, X is equal to A dot B. So an unsupervised algorithm to reduce the dimensionality of the data into the lower dimension spaces. NFA is a state-of-art feature extraction algorithm useful for a lot of features that are ambiguous and has weak predictability power. It can produce meaningful patterns, topics, and themes. Keep the structure of original data intact and make sure both bases and weights are non-negative. And NFA is uh, generally used for pre-processing stage for dimensionality reduction in tasks like topic modeling, classification, clustering, and regressions. And here we are going to discuss the, so if we have some task for like a topic classification or topic modeling, so the first step is called data loading, and then we have to do text pre-processing. And then once we do the text pre-processing, we have to perform exploratory data analysis. And here we try to understand the data. Here in text pre-processing, we try to clean the data and transform the data that can be fed to the model. And we have a feature extraction. We try to extract some of the feature that can be fed into the model. And then we are having topic modeling. So once we have a topic model, it will provide us the cluster. And once they provide the cluster, we can label the data. So that particular topic belong to this one of the classes. So once we have a label data, we will try to build some of the algorithm using the supervised learning. So we can use logistic regressions, naive-Bayes classifier, random forest, and decision tree. And when we build the algorithm, we have to do training and evaluation. So we have to see the metrics, what are the metrics we can check it. And we have to figure out what are the models that are performing best among all those, algorithm or model we have built, and validate on unseen. That is called unseen. It's not unseen, it's unseen data. Okay. So this is how we can load the data into the data from. We are using json.load ff and then just JSON normalize. So it will create a data frame. So once we have a data frame, then we'll do the text processing task. So as a part of text pre-processing task, we have to inspect the data frame to understand the given data, how many number of rows, columns we have that we can do it, what are the missing value or null value we have. If we have to maybe drop it. And if we need to rename the columns, we can do that, and try to remove the mask or personal data from the text if needed. Or if we want to extract, we can extract it. And after doing that, we have to make the text into the lower cases and remove the text from any bracket or curly bracket we have. Then also remove the punctuations marks if we have. Try to remove the number if needed, and that is based on the applications needed. Then lemmatized or stream the text to the is base form. After that, we have to extract the POC tag and remove all other extent which POC tag other than the NL. So the which POC tags other than noun, then we have to remove it. So we are trying, our focus is only for noun POC tag. We have to remove any pronoun text from that. So we will be performing all these tasks as a part of our case study. But these are some of the things that we can with respect to this case study, we are going to perform this task as a part of text processing. So once our data is clean, we'll try to and using this we can lemmatized or steam the code. So basically we are using a spacy model, a spacy library, and we are getting the stop words. What are the most frequent stop words coming for English word? And here we are loading the spacy NLP model. Here in for English language, core is a core module. Web4 it is used for web or news. So it will try to extract the information from all the web. SM is a simple model. And then we have defined one method that will pass the text and it return the lemmatized text. So here we are feeding the data to the NV module, and then we are getting the lemmatized text here. The text which is not in, we are removing all the stop word from the text and returning it. And we are returning the lemmatized text. After we have a lemmatized text or steam test, then we have to perform the ETA. So as a part of ETA, what are the things we can do? So we can visualize the data according to the word length. And we can also see what are the top word using the word cloud, what are the top feature or top words as a part of text analysis. And then we can visualize the top unigram, bigram, and trigram as a part of text corpus. So for feature extraction, once we have an idea, then we'll do the feature extraction. So we will using the TF-IDS matrix to convert the text into the numeric format. And what basically TF-IDF do is try to identify most important term within the topics. So we use that, and we can also eliminate some of the high frequency occurring words called we can stop word, and a very low frequent occurring word. that doesn't have any impact on the model. So we can remove those part as well. And this is how we can use the topic modeling. So we have already discussed about the what is the NMF. So NMF is a state of art feature extraction algorithm useful when there's a lot of feature and that are ambiguous and have a weak probability power. And it will produce a meaningful pattern, topic, and themes. Basically decompose or factorize the high dimensional vector into the lower dimensional representation. And those lower dimensional representation are non-negative. I mean, if we talk about the non-negative, it's a weight and biases and find the best number of cluster for the topics. So we are using sklearn and we are feeding the number of topics random and random state. And we are feeding here, TF-IDF matrix. So this is how we can extract the top 15 features. And after getting those top 15 feature for each of the cluster, and we can identify here. So from which, by seeing these patterns, it's a chase, dispute, card, range, transaction, fraud. So it seems like it's related to the fraud or something. But we have to check a lot of things: account, check, money, bank. So it's related to the bank account, payment, loan, mortgage. It seems like a loan related things. And credit card report, inquiry store. So it's looking like it's a credit or prepaid card. And this is some other. So this is how we can classify. So this is where we have to do some manual, manual labeling of. So this is topic one, topic two, topic three, topic. So it has so for topic one, these are the most frequent word occurring. And if it is a find a similar kind of words, uh, then it will try to label as a topic one. If it is a if for topic two, if it is account, check, money, deposit. So if any document that is containing most of the words similar to this one, it will classify to topic two. So now the next step is we have to map the topic. So the topic cluster, like a NFF will give you based on the number cluster, it's a 1, 2, 0, 1, 2, 3, 4. So we have to map those with the actual label here. So here it will give us the labeling of the modules. So once we have got the labels, we have now a text and then now we have a label. So now we can build the supervised learning to predict the, what I mean, we have one particular kind of a ticket and we can identify which department this ticket, belongs to. So for that, we have to, build one supervised machine learning algorithm. So now we have got the data and we have got the labels. And after that, what we have to do that we have to, create a data frame with a text data and label column. And basically we need that one, the label, and we need the, ticket text. We have to convert into then train X and Y and split the train and test data. Now we can build a supervised machine learning algorithm like logistic regression, random forest, exhibit, nav-based deep learning algorithm like LSTM and so on. And we have to pick the model which is performing the better. So we have to see some of the metrics like if it is a classification problem, we basically check the F1 score. But yeah, based on the use case, either what we need more accuracy or more precision or more recall. But basically F1 score is it try to manage all those things. So mostly we see the F1 score for classification problem. And we can see that if it is performing both, on training data and test data, then we can pick that model. So once we pick the model, then we have to, verify with the unseen data and see if it is able to predict the result correctly. So how to predict the topic? So we have already complained and we are applying the and this is how we can predict it. We are passing the model that will predict it. So let's go through the, the actual Jupyter notebook. So here we are, importing the library. So you can see that the first step is data loading, text processing, exploratory data analysis, feature extraction, topic modeling, model building is a supervised learning, and model training and evaluation. So here we are loading the necessary library, and we are using ticket here. So why we are using ticket here? Because it will show the progress, how much a task has been processed and how much it is remaining. And this is where we have to give the path of the data. We are opening the file, opening and reading the file and converting to the data frame. And here we are doing the data preparation as a part of text processing. So we are trying to analyze, do we have any header, footer, row, or what is the size of the data. We have 22 columns here. And then we are trying to see what are the percentage of the null value we have it here. So we can see there are a lot of value that are having the null. So we have to drop those columns, those are having the null. Either no or yeah, or row or columns. And one thing that we can see that source and complete source is a common to each of the source or slash, hyphen. So we will rename this column to some better name. So we will just remove the dot source, hyphen source from the data. So we have cleaned the column name, and now just see that how the data is coming. And we are trying to see what is the how much of value is null. So we can see that 57 to 41 record is null. So we'll drop those rows which is having the null. So once we see that, so we are mostly interested into this column only. What happened? So basically it's a customer complaint. So customer complaint is nothing but this column that will contain the information about the customer complaint. So mostly we are interested in these columns only. And after dropping the null value, we can see that we have now 21,072 rows. So let's prepare the text for topic mode. So we have to we have to clean the text. So we are trying to convert in the lowercase and then doing the text in square bracket, punctuation, line break, word with number, remove unnecessary white. So these are tasks we are performing it. So once we are done, we are limitize here using the spacy. And then we are, so here we have just defined the function, and here we are applying the cleaning the data for this column and storing into the df clean complaint column. So once we clean that, then here we are limitizing it in a different column. So here we have a column complaint, and here we have a limitized columns. So that will contain the limitized text. So once done, then we are have to do some POC tag mapping. And yeah, so we are checking only for NN only. Other POC tags we are removing it. So POC, complete POC, remove tags. And now we are performing the ADA. So based on the complaint size. So we can see that mostly the size of text is around 1800 kind of things, and frequency that is occurring around 40,000 as a max. Then we're trying to find top 40 words using the word cloud. So we can see that what are the most frequent word or occurring as a, or what is the most important word occurring in a corpus. We are removing the pronoun, and then we are trying to see what is the n-gram here. And then let me go there. Here we don't have all this data. I should have it here. So n-gram, and then we can see that it is printing So we have defined a common method for any graph. It will print, by passing the number of how many, how many word top word we need, and it's a one n-gram, unigram, or bigram. So based on that, it will return whether it's a n-gram, top 30 unigram, top 30 bigram, and top 30 trigram. So unigram is it is having the single words and their frequency. And then these are the top unigrams. We have a chase, account, credit card. These are the top unigram. And then we are having top 10 bigrams. So credit card, credit report, chase, credit, customer service. These are top 10 bigram. And then we are having the top 10 trigram. So credit card, chase, credit card account, credit card company, credit card, chase credit card. Okay. So once we are done now, what we have to do, we have to remove some of the masking word from that test, that we have removed it. So if you can see that completely, there is no masking word present here. Now we'll do the feature extraction using the TF-IDF matrix. So we are doing TF-IDF vectorizer and giving the 95%, that is most occurring word, and high frequency word, and that is the lowest frequency word. I mean the occurrence of what is it to. And here we are having topic modeling using NMF. So here we are passing the number of topics that we have already mentioned, 5, random state 14. And then we are training it here. Here we are trying to figure out, a top 15 words for each of the topic. So we can say that chess dispute. And using that word, we can identify, what are the topics. Using those words, we can have to identify or label it, topic one, which belongs to which cluster or which, a service line. So we can see some more data. Here we are converting into the numeric format. 0, 1, 2, 3. So create the best topic for each component in the form of 0 to 4. Okay, so this is what we are doing that. So best topic for, assign the best topic to each of the component in topic columns. Here we are trying to group. What we are trying to do, we are grouping the topic, and we are trying to retrieve top 5, top 5 topic from each of the group. So this is a 0 group, 1 group, 2 group, 3rd group, and 4th group. And using that, what we have to do, since card hasn't end of grade, and we have to think, for which category, this cluster is belonging. For this category, this cluster is belonging. So here we have to do the manual mapping. So 0 and belonging to. So after going through all those, text, and based on the understanding of the domain, I have mapped those group into the 0 is belonging to the theft, dispute, or reporting. This is called frauding. 1 is belonging to the bank account services. 2 is topic is belonging to the mortgage or loan. 3rd belonging to the credit card, prepaid and card, and 4 is other. And here we are mapping it. So once we have mapped it, so we are having a data frame that include complaint numberize, complaint POC remove, complaint clean, and topic. Now we have got the label. Here we have got, once we have done that, we have got the label as well. So info. So what we can, if we can see that, see, we have got the label it here. So what we need, we are trying to now build a supervised model. So we don't need a lemmatized complaint POC remote, complaint clean. We don't need this data now. We just need a complaints, actual text, and the topic. So we'll drop all lemmatized complaint POC remove and complaint clean. to build the model. So we just need a component and topic model. So we are creating our copy with these columns only. And now this is our data for the building the model for topic classification. So from here, we are done with the topic modeling. And from here, the topic classification task has been started. So we are trying to apply the supervised machine learning, and we have to do your counter factorizer. And before going that, we are trying to see if there is any data imbalance. We see that we have some amount of data imbalance, but I do not see much here. So if need in future, we'll try to handle the imbalances. So we'll try to implement a supervised machine learning algorithm using the logistic regression, decision tree, random forest, and naive Bayes. So here we are importing all the dependent library and splitting into the train and test data. We are checking the what is the size of shape of the training and test data, and this library are required to build the model. Here we are defining the evaluation matrix. So how it is going to evaluate it. So we are trying to see the accuracy, precision, recall, F1 score, ROC RCIA score area, and if we pass the model and the parameter grid, so it will build the model using the grid search. That is a good force approach with a different combination of the parameter. And yeah, so here we are combining the parameters. So this is for this parameter we are passing for logistic regressions. We are passing the C, penalty, solver, max iteration, and class algorithm, class bit. So it's a balanced. And we are running the model here, and we are evaluating for both our train data and test data and see the report. So on 10 accuracy, it's a 96%, and testing it's a 91. So we see that it is performing very well, and we do not have any, we do not have any overfitting problem or underfitting problem. So logistics regression is able to, perform well here. So we can check it. What is the precision, recall, F1 score? Let's do for decision tree. The same thing, we are passing the parameter for decision tree. And then for random forest, similar way. And this is for never base. So we can see that if we check it here for decision tree, this is training is good, but if you check the testing data, we are having overfitting problem. So let's check for random forest. So random forest is also having some, overfitting problem, and multinomial name base are also having. It is performing well, but accuracy is better with the logistic regression. So what we'll do that, these are the report we have generated it. So in that we can see that logistic regression is working well. So even its precision is good, recall is good, reference score is good, and ROC curve area is also good. So we will use a logistic regression model, for our predictions because it is performing well with the train and testing data and with all those metrics. And here we have constructed some of the data for testing our model on unseen data, and we convert it into the data frame, and we are here providing the mapping. So what mapping it is belonging, and this mapping we have passed to the topics. Okay, so we are passing the TF-IDF, and those metrics we are passing to the logistic regression model to predict it, and we are checking for the predicted level. And predicted level. So it will return the predicted level. So apply predicted error. So for each of the data, it will take each data, apply and predict the level. So we can say that I cannot get from JS. So it's a mortgage and loan, and basically the ball bill amount of credit is a credit card, salary account is a bank account services, fraud and email trigger. So it's a theft or dispute. So what is my procedure to know CIBIL score? So basically it's a credit card, prepaid card, and it's a banking account service. So we can see that the model is performing well, and it's able to predict the complaints correctly. So this is all for today, and if you like my session, please like and subscribe my channel. Also hit the bell icon so that you can get notified when the any video is getting uploaded. And thanks for watching.